Now, David, and I might have shown the other class, maybe we didn't do it in here. On the web page, I've got the
other class.
No, I mean just the other day. We've got the business packet answers. That's this sheet with things worked out. I'm going to give you another packet tomorrow with a variety of optimization, which is 4.3, and related rate, which is 4.5. So that's called the Anton packet, which is just the authors of the book that I copied it from. So there's some worked out answers for there. And I've got this this link here for optimization hints, which is this thing that we've had up on the board at various times. And then I've also got this related rate. I don't know, hints is the right word. It's probably steps or whatever. But here is this, and this is something I wrote last year, and I think well, no, I don't think I put that up yesterday. This kind of is another list written out of the paragraph that was in your book in section 4.3, where it talked about the related rate. Okay, and it just had it in a paragraph form, and I've kind of written it out in some steps. Now, again, this is just something that I wrote last year, and I don't know if it's complete. There might be some changes you would make here. For example, number one, identify the various amounts or distances and rates in the problem. This would be like problem 4 and problem 7 I'd be talking about now in the book. Draw and label a diagram. To be honest, those are probably backwards. I mean, in some problems, you'll probably do a picture first, and then write down the different amounts because you'll put your labels on your picture. Okay, typically. And so those could be backwards. Then step 3 says write an equation that relates those amounts. And the key to this then is 4 and 5. Differentiate both sides with respect to t, and then substitute the given values and solve. The problem, again, that people have here is when do I substitute numbers in, and when's it okay to substitute in, when, I just see people messing that up a lot. And essentially, what you want to be able to do is understand the process, understand what you're trying to do, and not memorize 6 steps, but understand the big picture of what's happening, and then it will make sense. That's what you should work on trying to do. And of course, that takes time, and it takes time and effort. You've got to be practicing them and spending time with them, and then coming in and ask questions if you need to. But if you're just going to kind of try to memorize steps, you might get away with it to a certain extent, but it's not going to be very successful. But if you are going to, out of desperation, just try to memorize something, well, memorize this, that the only numbers you can plug in at the beginning of these rate problems are those that are constant throughout the problem, those that do not change. Any values, any numbers that change throughout the problem only are plugged in step 5 after you've done the derivative. I mean, if you think about it, if you plug in a bunch of numbers and then try to do the derivative, well, the derivative of a number is just 0. You'd be getting 0 all the time. You wouldn't have any variables in the problem. And of course, the very name variable means to vary, to change. Okay? That's the difference between something that's constant and a variable. All right. And then check in. I put down a check answer for the correct side because your answer is typically a rate. And you want to make sure you have, a positive rate means it's that the amount is increasing, and a negative rate means it's decreasing. We're going to talk more a little bit about the how you answer those questions. Okay, so let's go ahead and take a look at number 4. I'll put this up again. I want to take it down for a minute here a little bit. All right, so number 4 had this lamp post and the person And I know a lot of you, most of you, did this in class yesterday, and you had it pretty much started for you in the book. Okay, now keep in mind that you will have to be able to draw this picture and set it up without that help like you had. They talked about a man 6 feet tall, walking in front of a lamppost that's 12 feet tall. His shadow we'll call S. How far he is away from the lamppost we'll call X. And they asked two questions. They asked how far, when the man is 6 feet or 10 feet away from the lamppost, how long is his shadow? And how fast is his shadow lengthening? Those are the two things they asked for. So notice I did step 2 first. I wrote, draw and label a diagram I did first. So let's put in the numbers that they give me in the problem. Now I've put some of them in. The man's always going to be 6 feet tall. The lamppost is always going to be 12 feet tall, so those aren't going to change. But what are some of the other numbers they tell me in the problem? X equals 10. We do not want to write that on our picture, because as the man walks, that will be changing. So we don't want to put that in the picture, and we don't want to put that in the equation until the very end. Constants can go into an equation in the beginning, but not things that are changing. What else? He's walking 7 feet per second. Now, should that be positive or negative? Why? He's moving to the right, or more importantly, because X is increasing. Because X is increasing. Now remember, the negative will not be in the paragraph. If the problem would have said the man's walking towards the lamppost, then we would have had X prime be negative. And that will make a difference when we plug it in. X prime would be negative. Since he's walking towards the lamppost, X would be decreasing. So therefore, X prime has to be negative. All right? And they don't tell us anything else, but they do tell us what they want us to find, which is, actually they want us to find two things. The length of his shadow, which would be S, and the speed that the shadow is lengthening, which is S prime. So, step 3 that I had up there a minute ago said, write an equation that relates those things. Now, they had helped you out there, but X and S are what I have in my picture. That's all I have written down as information, so I need something that relates X and S. Well, it's going to be similar triangles, as you notice. Now, where some people might get off track on one like this, if you didn't have the example to look at, is you might have drawn a hypotenuse here and labeled that, because there are no values in it. That would have added another variable to it that we don't know anything about, but you might have tried to do a Pythagorean theorem thing. What would dissuade you from doing that would be the fact that that would bring a variable into play that's also changing as the man walks, and yet they don't give us any information about it, so we probably don't want that. All right, so in our big triangle, we have 12 for one side. We have X plus S for the other side. In the little triangle, we have 6 over S. We have a proportion. We cross multiply. We get 12S equals 6X plus 6S. We get 6X equals 6S. We get X equals S. It almost seems too simple to be that way. Now we can go ahead and do our derivative, which tells us S prime is equal to X prime. Now, a few people in the other class, and this is a legitimate question, they said, no, I'm still not sure why we're writing X prime. We never used to write X prime. Why are we writing X prime? With respect to t. So this is dx dt, this is ds dt, and that's X is just, we wouldn't have had to use X there. We could use Y or Z or A or B, right? There's nothing special about the fact we used X there. These are all with respect to time. X is just a length, just like S is just a length, and they're changing with respect to time. So X is actually an output here, and S is an output. It's a length at a given time. So the derivatives are all with respect to time. That's different than the optimization problems, okay? That's different than those problems. All right. Now, that's very easy now at this point. So if X is 10, then we just come in and we plug in. So if X is 10, S is 10. And if X prime is 7, then S prime is 7. So it just turns out that in this particular case, since the man happens to be half the height of the pole, that his shadow will lengthen at the same rate that as he's walking. It's just kind of a coincidence. Now, one thing I want to comment on in this problem, sometimes on these shadow problems, they add another question. How fast is the tip of his shadow moving? Is that a different question than how fast his shadow is lengthening? What if it would have said, how fast is the tip of the shadow moving? So what would the answer in this problem, what would be the answer to how fast the tip of the shadow is moving? 14. Why?
Because you have to count for the speed of him walking and the speed of the shadow increasing.
The shadow is growing at 7 feet per second. But as he walks, remember, if this is where he's at, the start of his shadow, and here's the end of his shadow, if this part is growing at 7 feet per second, but he's also moving at 7 feet per second, right? Both those things are influencing the tip of the shadow. It's kind of like you're driving in a car and you drop, you're driving 60 miles an hour and you drop a piece of paper out, right? At the instant you drop it, the paper's moving 60 miles per hour, right? So if you would throw something ahead as you're driving 60 miles per hour, the paper would actually be, or whatever you throw out, would actually be moving at 60 miles an hour plus whatever you throw it at. Okay? It would have both those components. Or another way to think of it is this. The tip of the shadow from here, moving from this direction, would be x plus s. So the tip of its rate would be x prime plus s prime. So it would be both of those added together. So keep that in mind. Those are two different questions. How fast is the shadow lengthening? That's the rate of change of s. How fast is the tip moving? That would be the rate of change of this whole length. Okay. Number 7 had another aspect to it. We had a rectangle. Both sides are growing. Let's see. Put that up there. Ooh. Aren't both sides increasing? Okay. Oh. Both sides are increasing. So again, kind of like dragging with your mouse and lengthening one side, lengthening that side. And if we want to label those length and width, that's fine. Label them X and Y, that's fine. But the book tells us several things. It says, okay, the length, we'll call that X, it's growing at what rate? 2, length. And the width is increasing 3. And we want to know how fast the area is increasing. So that's A prime, or okay, so that's A prime we're looking for. And they tell us at the instant when X is, that X was the length, I think I said. Length is 4, and width is? They're both switched. Okay, so X is the width and Y is the length. There you go. So X is the width and Y is the length. Okay? X is the width, Y is the length. All right. As long as they're matching, we're okay. As long as they act forward, the two go together, I think we're good. So step 3 then was write an equation that relates these quantities. Well, what's going to relate area and X and Y is clearly the area formula, X times Y. So at this point, since we have all of that information, there's no need, to get X in terms of Y. When we did the cone problem, we had volume and R and H, and we wanted to get that in terms of just one variable. That's because the problem only told us about volume and height. It didn't say anything about radius, and that was going to be an extra variable that would get in the way. Here, there's no need to get rid of the X or the Y because we have information about the X and the Y, which is fine. But the thing that most people messed up on here is when you do this derivative, you have to do the product rule. You're doing the derivative with respect to t, which is like the gateway test. However, in the gateway test, we were doing it with respect to x, so we never had any x primes in those problems. But here we will have an x prime, because we're doing it with respect to t. So the derivative of the x is 1, leave the y alone. So the derivative of x is x prime, leave the y alone, plus x left alone times the derivative of y is y prime. Right? That's the derivative of both sides with respect to t. We have all the stuff we need to plug in, so you plug it all in, you get 22. Now, since everything was increasing, everything comes out positive, and so the area is increasing at 22 whatever square centimeters per minute or whatever it was. Now, or per second. I want to talk just a second about how the question is worded. If you're going to give your answer as just a number to a rate, then you have to make sure and you have to match your answer to the question. Now, increasing is easy when it's positive. The question is, at what rate is the area of the rectangle increasing? So if you just put 22 centimeters squared per second, you're good. If you just had that for an answer, you'd be fine. What if, and this somewhat depends how picky I'm going to be, but I might be this picky. What if this would have said, what if the area came out negative, okay? So it was decreasing, the area was decreasing. What if the question would have said, at what rate is the area of the rectangle decreasing? Would it be proper to say negative 22 square centimeters per second? Because wouldn't that be a double negative? Right? You wouldn't want to say it's decreasing at a rate of negative 22 centimeters per second. Right? So if the question already said at what rate is it decreasing, it would be proper to write the answer as 22 centimeters squared per second. Now, if you're at all bothered by that, then don't give your answer just as a number. Write out your answer. Say the area is decreasing at 22 square centimeters per second. Okay? Now, if you'd rather use the negative that you got for your answer, then say the area is changing at negative 22 square centimeters per second. See the difference there? Okay? So the negative tells you it's a decrease. You use the word change, which could be either positive or negative, right? But don't use decreasing and negative both in your answer. All right. So not a huge deal, and like I said, I may not even be that picky about it, or I'll try to, what I might try to do is just say changing. At what rate is it changing? That way, if you give your answer just as a negative that it came out, that would be proper then, and then you won't have to worry about that. Okay, so I'm not trying to trick you on that. I just want you to notice that, you know, that's an issue. That's something to consider. All right, so that's the related rate stuff. Again, I can't emphasize enough that you only put changing quantities in, you only plug those in at the end after you've done the derivative. After you've done the derivative. Well, when we get some work time later here, you're going to get a chance to work some, and you'll probably have some questions about that. All right, let's take a look at the business packet, and I want to look at 19 and 20. I want to talk about getting those set up, and I know there's some questions about that. I also want to just quickly go through the answers to the earlier ones if you'd like to see those. I'm just going to make a couple of quick comments about the early problems in the business packet. If you've got something more specific, go ahead and speak up, okay? Talk to me individually or speak up as I'm going through it here. But on 10, they called this thing the demand function, the little p, and we had said that little p was the price per unit. Well, keep in mind that how companies set the price for their product isn't a complicated thing. And it's based on supply and demand, right? The bigger the demand for their product, the more they charge for it. And so typically the price is called the demand function. Based on demand, what price can we set? So it's a changing amount, as you saw in your apartment and radio problems on 19 and 20. So the demand function is simply the price per unit, so you need to take that times the number of units, x, to get your revenue. So here's our demand function. We multiply that by x. That's our revenue function. Profit, of course, is the revenue minus the cost. That gives you all this. And then you just go through and you set the derivative equal to 0, and that's your max. Now, keep in mind that in the answers to the packet, I did not fully justify the max and min. You probably need a number line or something like that here. Okay? So x is how many units we should make. Well, we can't make 54.772. I did not check 54 and 55 in this one because They didn't ask me how many units we should make. They asked me what price should we charge. So you could take this number, which is actually the max, plug it into the price equation, and get a price to charge. And then that would be an okay price to charge based on this maximum. Even though this wasn't, I didn't round that to 54 or 55 units, okay? If they just want to know how many units should we make, then yes, we probably should have taken 54 and 55 and plugged those into the profit and see which one was the max, okay? All right, number 12, same thing. Let's see, yeah. So number 13, I wanted to make a comment about 13. On 13, they asked for average cost per unit. So you had to take C and divide it by X, okay? So you take the C equation they give you, divide it by X, that gives you cost per unit. You do C bar prime, you come up with X equals 3 for the minimum, because they wanted minimum cost per unit. And that's at 3. Now again, I did not do a number like, again, list of candidates is a great way to justify max and min, but in a lot of these problems, we don't really have any other candidates. A lot of times we end up with a single candidate. So therefore, a number line can tell you that, okay, that is that's my max. Now, the second part of 13, they asked 2 questions in 13. The other one was, show that the average cost per unit is the same as the marginal cost. Now, if you don't remember, back on the previous page, we had said marginal cost is the derivative of cost. I'm talking about the C equation now, not C bar. So, if we plug a 3 back into the C bar equation, we get 17. But you also have to plug a C into the C prime, or excuse me, a 3 into the C prime equation. That's the marginal cost. You have to know those terms for the quiz on Friday. I would ask that. You have to know that marginal cost means the derivative of cost. All right. So if you plug a 3 back into C prime, you also get 17. And it's not important right now why those two are the same thing. But we'll leave that for another discussion. Okay? 15 is a pretty similar question. They give you a profit. They give you a price function. It's very much like 10 and 12. So let's get into number 19. And number 20. All right. Now, on number 19, we're going to let X be the number of radios. Now, once we make over 100, we're going to cut the price. We want to encourage them to order big orders. So if they order 100 or less, it's $90. How much profit are we going to make? Under 100 radios. $30 a piece, right? We sell them for 90. They cost us 60, so we're going to make $30 on every one. So what's our max profit up to 100? At 100, right? It'd be 100 times 30, which is what, 3,000? So our max profit up to was clearly if they'd order 100, we're making $30 on every one, so we want them to do more. However, once we get over 100, we start lowering the price. So at some point, we can't let them order 1,000 or 10,000 because if we keep lowering the price, pretty soon we're giving them away for free, or they're going to be below our cost, right? And we're going to lose money. So we want to be careful of that. So we're going to give them 10-cent reduction every radio over 100. So if we're going to let X be the number of units, which is what we almost always do. I know in the packet it said X is the number of units. Now there are times where you wouldn't have to do that, but most of the time we will. Now how you go about setting this up, there'd be a couple of different ways you could. Somebody want to tell us how they set it up? How they set up? What equation are we looking for here? What equation am I trying to write? In the end, I'm trying to get profit, aren't I? I mean, remember, step one in these problems is identify what you're trying to optimize, right? We want to max profit. So in the end, I want profit. Now, what do we know profit is? R minus C, revenue minus cost. So some people would try to break this down and say, well, let's do the revenue first, and then let's do the cost, and then we'll subtract them. So that might be a good way to do it, okay? And but some people just go right into the profit. It doesn't matter. You should end up with the same thing. So what would R be? Well, what's revenue? Well, revenue is the money you bring in. Revenue is the price per unit, P, times X, the number of units, right? All right. So let's just do the revenue for one radio, right? What's our revenue going to be for one radio? Well, what are we going to sell them for? 90 to start with, minus what? No, now 60 is getting into the cost. See, I'm just doing revenue. Revenue is the money we bring in by selling the radios. But we're not going to sell them for 90, right? What are we going to do? We're going to take off 10 cents for every radio over 100. So how do I write that? 0.1, parentheses. This would be a good way to write that. Okay? So if X is 101, if we sell 101 radios, this would be one 10-cent price reduction. If X is 102, it would be two 10-cent price reductions. Now, that price is for all the radios, even the ones below 100, right? It's I think if you read it carefully, it says that'll be the price for all the radios they order. Okay? So if they order 101, they're going to pay $89.90 for all 101 radios. Okay, now what do I have to do with this then? Yeah, this is the price for only one radio. So I have to multiply that by the number of radios to give me my total revenue that I'm going to bring in. Okay, what's my cost? 60 times number of radios. That doesn't change, no matter how many they order. So now my profit is my revenue minus my cost. So take that minus that. That's your profit equation. Now I would suggest simplifying it. Okay? But you could use your calculator to do that. Just be careful if you ever write X parentheses, then the calculator thinks that's a function and not multiply. You got to put a time sign. Notice I put my X at the end. But if I had put the X at the beginning here and had X parentheses, it would have thought that's a function, X of something, not X times. So I'd have to put a multiply sign there, so make sure you type them in correctly. All right, so I'm going to leave the rest of that for you on that one. Yes, Zach?
Wouldn't the X minus 100 mess with things for anything below 100 though?
Yes, it would. This equation, let me show you what I put in my answer thing. What I was doing here is saying for X less than 100, then the price is just 90. And that's where we were saying the 3,000 a minute ago. We know that'll be the profit. The max profit will be right at 100 if we're going to sell 100 or less. But once we get over 100, then this equation will be fine. So yes, this equation is only good for X is over 100. So we go through here, and if you go ahead and work this out, and again, I'll let you can finish that on your own later. But when you do the derivative, set it equal to 0, you get this. Now again, you could say there are no endpoints. Now some people might call 100 an endpoint, so I kind of did it two ways here. On the one hand, I did 100 as an endpoint and 200 as another candidate, and I looked at those two and said, hey, we made more money doing 200 than 100, so 4,000 is our max, so 200 radio is what we should set. But you could do it as a number line, and you could say, okay, it's always increasing, because it is. I mean, let's face it, when you sell more than 100, or less than 100, your profit's always increasing up to 100. And then it keeps increasing up until 200, and then it's decreasing after. So probably, again, with a number line, you should always have a sentence in there. That's where we use the word always. You know, P prime is always positive before and always negative after, so therefore P is always increasing before and always decreasing after, and so that makes that a max. Okay? So don't forget about that aspect of it. Okay? So there you go. But again, the secret is setting this part up. And I have no great hints for you on how to set that up. That's just back to old Algebra 2 stuff, and you've just got to be able to think your way through that. I don't have a great answer for you there. All right? Now let's look at 20. Now in 20, it says you've got these apartments. And every time you raise the price $30, the rent, you're going to lose a renter, right? There'll be one less occupied unit, which makes sense, okay? So again, we've got revenue, we want our max profit. So we've got to come up with revenue and we've got to come up with cost. You don't have to treat them as separate. I just think for some people it's easier if you just focus on one thing at a time. So where's our revenue coming from? Our revenue is the money we bring in, which is, as the property owner, it's the rent that I get. Okay, so what's the rent? Well, back up. What is X going to equal here? Number of occupied units. So a good, if you're following what we normally do, we would let, how many P's in occupied? One. Just kind of froze up for a minute. 2 C's, 1 P, right? How many C's in vacuum?
2 U's.
1 C, 2 U's. That word has haunted me my whole life. I lost the 5th grade spelling bee
No.
on the word vacuum.
Did you really?
I did.
It's
It's really good.
So is that when you gave up?
It was me and one other girl.
Is that when you wanted to?
No, it wasn't one of those. It wasn't one of those. It was written. It was a written. It was just in my 5th grade class for who was going to get to go to the Fillmore County spelling bee. I mean, so it was just in my 5th grade class.
So is
But in 4th grade, I had went and got like 3rd or something. Big
Nice.
ribbon. I got this great big yellow ribbon I used to wear at school. All right. That's not. Yeah. See, I'm well rounded. All right. So the sad thing is, you guys would really believe that I would wear that big yellow ribbon. All right. So. Oh. Yeah. So, yeah. All right. So we start off with X being the number of occupied units. All right. So what's my revenue? Okay. So what am I going to start with here? So right. Well.
550.
Okay. 540. I'm going to for sure charge 540. Plus, I'm gonna gain $30. Now this is just for one apartment, right? This is just for one apartment we're doing now. I'm gonna gain $30, or every time I add $30, I have one less apartment. So what I need here is 30 times something. 30 times 1 would mean I'd have only 49 apartments, right? 30 times 2 would mean there'd be only 48 apartments occupied. Are you following my reasoning here? If I add on 3 $30 increases, I'm only going to have 47 apartments occupied. So what number here would give me a 1, then a 2, then a 3? 50 minus X. So if I have 47 occupied units, which means X is 47. So when X is 47, this would give me 3 $30 price increases. Does that make sense? And if they're all occupied, if X is 50, then I have 0 $30 price increments, and there you go. I mean, that's what you have to think about. So this would be my rent for one apartment based on how many are occupied. Okay, so what do I need to do then to give me the total revenue? I need to times all that by how many occupied units I have, which we said that is X. So that's my revenue. This is the rent for one apartment times the number of apartments. So what's my cost? It says it costs $36 for cleaning and utilities and all that stuff for each occupied unit, right? So that's 36 times X, since X is the number of occupied units. So that's my cost. So they're saying then cost the same thing for the empty apartments because we don't have to upkeep or whatever. Okay. I mean, you'd think you'd still have the heat on maybe or something. Anyway, maybe not. I guess, maybe not. So profit then is revenue minus cost. So your profit equation is going to be the top one minus the bottom one. Put that into your calculator to simplify it, and so forth. And then you're wanting to maximize that. So therefore, coming back to this, okay? So there's my revenue minus my cost. It simplifies down to that. Now, the other thing we said the other day, when I see this profit equation, again, the first thing I see is an upside down parabola. So, negative with the x squared. So, thinking about your justification, you know, if you notice that, you could just write a sentence that says the profit equation is an upside down parabola, you know, maybe a little sketch of it, and just say, so the max is going to be when the derivative is 0. And so there's your justification of why it's a max. So do the derivative, comes out 33.4. Now, clearly, you're not going to have 33.4 occupied apartments. Somebody's only using one of the bedrooms or something, I don't know. So it's either going to be 33 or 34. Okay, so I went ahead and showed that here. So put 33 back into the profit equation, put 34. It's not really a list of candidates. Sort of is, I guess. We already know it's a max, but which one of those is it? And this one's just a little bigger. So 33 units. But that doesn't answer the question. The question is, what rent should we charge? What rent should we charge? So for 33 units, the rent we would charge, we'd come back to a revenue equation, right? Put a 33 in there. That would be 17 price increases. 17 $30 price increases. So that came out to $1,050. Should be the rent. Yes?
Why couldn't you just put X into, just like not do the P33 and P34?
Because you're right in the sense that was the same rationale I just mentioned a little bit ago on that other problem, right? With the 43, we put in the 54.772 and we made that the rent, where we made that the price we should set. The difference in this problem, I would say, is in that problem we were just setting a price for, and it was based on that demand function, right? But the demand function was a continuous curve, so the price could have been anything on there. In this problem, the price was set up to be in $30 increments, I would say. Now, you're right. Who's to say they couldn't set the rent at something in between there? But I think the way I read the problem, now, I don't intend to really make it that big a deal in the problems I give you. And if you had all your work and you used 33.4 and you came up with something a little different, you know, based on that, and you plug that in, I'm probably not going to make a big deal about that. Okay? But that's why I did it in this case, because I felt like the rent should have been in $30 range. Now, somebody in the air class asked, they said, well, that seems weird that the rent's actually going to double. I mean, so this person, what we're saying is this owner would be better off having empty units, right, than filling them. And based on the information we were given, that's true. Now, where'd that information come from? Well, it would be based on the rental situation in that community. For example, in Kearney, since I've been here over 20 years, there are a lot of new apartment buildings. Well, our population has grown, number one, but, you know, if there's a lack of good apartments, then maybe this information would change. Maybe with $30 price increments, you wouldn't lose occupants. Maybe you could charge $1,050 and not, you know, and still fill the place because there was a lack of space. But if there's plenty of good apartments around, then, you know, you may be better off having some empty. Because remember, it costs you also. So, you know, it might be, for various reasons, you might be better off setting the price where you do have some empty apartments. I mean, there's a lot of things in play there. Yes?
If you doubled your price, you probably end up with about 50 empty units.
You kept, well, now we said double the price from 540. 540 is, you know, just kind of that made up number if it was totally full. 540, I mean, really, 1,050 in Kearney, that's pretty expensive apartment. But on the coast, you know, at various other places, that would not be very expensive. Okay, and if you own a home, a mortgage on a $200,000 house, that's a pretty nice house. But a $200,000 house, but that's not extravagant by any means. But a $200,000 house, the mortgage is going to be $1,500–1,600 a month. Okay, and that doesn't include heat, utilities, and things like that. So, you know, that's not a crazy amount. All right. So we're gonna stop at this point. I'm gonna let you get to work. Now there will probably be some questions come up that I can answer for the big group, but I'm gonna let you get started working. Okay, on this. Really, between now and the quiz, there's not really much new to talk about, other than the questions and the things that come up with. Now we've just scratched the surface on the different types of problems we can do here. using these techniques. So now it's just a matter, we got to get in, dig into it, we got to start working them and making sure you can do them on your own and not have me set them up for you. Okay? Because clearly this quiz is going to be a lot of story problems, and you're going to have to set them up and go through the steps. So here's your assignment for tomorrow. In the business packet, you can go ahead and just circle them here. We're going to do 21 and 23. Now, 23's got this little graphing symbol next to it. It's from an older book, when graphing calculators are kind of new, and so they're like, hey, here's what you can do with your graphing calculator, And so they throw in at the end, they say, use your graphing utility to graph it and estimate. Don't do that, okay? Just work 23, when it says write the cost equation, and then find the minimum value. Go ahead and do it the way we've been doing. Okay, so 21 and 23 in the business packet. Then in 4.5, the related rate problems, and it might not be bad to use your in-class time on these related rate problems because that's the newest thing. And that way there's some things I could probably help you with as you go. So on the line that says 4.5, let's do the rest of where we left off after number 7. Let's do 10, 12, 16, 23, and 26. Get into a couple cone problems. I love those cone problems. Okay? 10, 12, 16, 23, and 26. So that's our homework for tomorrow. Okay? You got the rest of the time to work. Let's use it well. Good? Well? Use it well. Use it well. Pretty good. How do you spell? Yes. Yes. Oh, I Hey, time out. Give me 1 second. Or, well, more than 1 second. Maybe more than 1 second. Well, but it's a timeout, so time is stopped. The clock is off. So, okay, time. All right. You froze time. 30 seconds. This is a full time. All right. Now, listen, on this one, the other thing I meant to show you was, and I guess I'm still recording, so let's. All right. We could have let X represent something else. And I'm not sure it makes it easier, it's just different. We could have let X equal the number of price increases. Now, usually what happens when you do this is it makes one part of it easier, but it makes another part of it harder, so it's kind of a wash. If we would do that, then what would our rent be? Well, our rent would be 540 plus what?
30x.
30x. So it makes that part of it easier. That's the rent for 1 unit. Then we have to multiply that by number of units. Well, what would number of units be? Well, it wouldn't be X now, like it was over here, right? What's the number of units? Well, it's 50 minus the number of price increases, because every time we have a price increase, the number of units goes down by 1. Right? So 1 price increase, we have 49 units. 2 price increase, we have 48 units. So it just changes it a little bit. What would be the cost equation? The cost equation was 36 times what? Number of units. Well, what's number of units in this problem? 50 minus X. So our cost would have been that. And then our profit would be revenue minus cost. And then when we did P prime and set it equal to 0, we'd come up with X equals 16.6. And then we would check 16 or 17, and what we would come up with is, okay, we would have 17 price increases, which, of course, is what we said a little bit ago. 17 price increases, and you do 540 plus 30 times 17, you get the same answer, 1,050. So it is possible sometimes to not use X as a number of units, but to let X be the number of price increases or decreases, because that's pretty common in these problems. That every time you decrease the price, you're going to sell more. Every time you increase the price, you're going to sell less. So it's not uncommon to have that situation in a business problem and to let X be the number of price increases or the number of price decreases. Okay? All right. So anyway, thank you. Now go back. And that's yeah. And that's exactly how it
We can go watch the video. I know.
Yeah.
Okay, so again, I think the ones in the book would be a good place to start, but that is totally up to you. But there are some things, some issues that come up on these related rate problems that we haven't gotten into yet, and so the sooner we do, the sooner we get into those, the better, probably.
What does it mean by a straight section?
Right.
Straight.
So it's not doing that.
Okay, so then.
So it makes a triangle when you draw the straight.
So 3 miles from it, so everything.
No, like the snowmobile problem. Yeah, like here is a transmitter. Here's the highway. And the truck's going this way. The transmitter's on the other.
Okay, my
Well, that's because my S is going the other way.
I'm pretty sure it's the same.
normal.
It might be the same.